as you're looking at these, I'm hoping something kind of jumps out to you as being off. What do you notice that kind of makes you a little uncomfortable? Yes? There's a negative under the square root, and we've always been taught what? You can't do that, right? Well, that's not entirely true. Technically, you can. There is this thing that you need to know. Actually, I'm going to put it, we'll do it at the bottom here. There is this letter called I. And I is representative of the square root of -1. So in other words, if I was given a problem like this, and I was asked to solve it, what I could do is I could think about this as the square root of -1 times the square root of +9, right? If I know the square root of -1 is I can simplify that, and the square root of +9, I know what that is. It's 3, isn't it? So I times 3 would be 3i. So what I allows us to do is it allows us to simplify radicals that have negatives underneath them. Okay? I is an imaginary number. Now that's not a make-believe number like a fairy tale. It's imaginary in compared to all the other numbers that you're familiar with are known as real numbers. So imaginary numbers is a whole different set of numbers. They have their own graph. You know, we're used to graphing on our XY plane. That's a real coordinate plane. The imaginaries have their own coordinate plane to graph on. So there's a whole different world that's imaginary in math. It sounds really funny to say that, though. So this is known as imaginary. And I usually use the term imaginary because imaginary and I, it just goes together in my head. However, the official name of them are complex numbers. So anytime you have an I in a problem, you have a complex number. Okay? So, I need to think about this whenever I see a negative number under a radical. All right? So if I go up to number 1, I have that negative sign, don't I? So I need to think about this as the square root of -1 times the square root of positive 384. Yes? So I have an I here, and this one I can draw a tree for just like I have been. So 384, that would be 2 and what? Let me see. 384 divided by 2, and 192, that's going to be 2 and 86. Is that right? 96. 96. Is 96 divisible by 12? Yes. 8 and 12. 4 and 2. 2 and 2. 12 would be 6 and 2. 3 and 2. So we got all sorts of numbers there. What can come out? A 2. Another 2. And I think another 2. Yes? And what's left inside? 2 times 3. Because those were the 2 loners. You following me? Where does the I go? It's outside. Okay? So it's going to go right there. It always goes after the number. So 2 times 2 times 2 is what? 2 times 2 is 4 times 2 is 8. So I have 8i radical 6. And that's my answer. So it only changes what we're doing just a teeny tiny bit. Okay? Number 2. Well, this would be the square root of -1 times what? Square root of positive 144. What is the square root of -1? I. What's the square root of 144? 12. What's I times 12? 12i. Easy? What about number 3? How's number 3 different? Number 3 could have been on yesterday's notes. There's no negative, so I don't need to worry about an I, right? I'm just going to draw my tree and go from there. 72 can be broken down to 2 times what? 36. 6 and 6. 3 and 2. 3 and 2. What comes out? I have a pair of 3s. That means I have a 3 outside. I have a pair of 2s. That means a 2 outside. And I have one loner 2. He's got to stay at home. So I have 6 radical 2. So? Okay. I want you to try and finish the problems there. Try and finish 4 through 8. And I'll catch up with you in a few minutes. All right, talk me through this. Negative 54. That means I have square root of what? Negative 1 times square root of positive 54. Square root of negative 1 becomes I. 54 I can draw a tree for. It's what? 9 and 6. Okay. 3 and 3. 3 and 2. What comes out? A 3. So I have a 3 outside. I also have I outside. And what's inside? The 2 loners. 3 times 2 is 6. Good? Okay. This one. Do I have an I? No. So let's just draw a tree. What multiplies to get 294? Anybody? 14 and what? 21. Let me just verify. 294 divided by 14. Okay. 14 and 21. I like that. That'll make my tree nice and small. If I couldn't come up with that for some reason, I can always just divide by 2, and it'll get down pretty quick. 3 and 7. All right. I already have a 6 outside. What else is going to come outside? 7. And what's inside? 2 times 3 is 6. So what have I got? 42 radical 6. Easy peasy. Number 16. Please tell me you can do it in your head. I have a 4 outside. What's the square root of 16? So what's my answer? 16. All right. Coming down to number 7. It's that 150 again. We had that yesterday, didn't we? So this is 6, and then I have square root of negative 1 times the square root of 150. Yes? So that's 6. That's I, right? And then 150, 15 and 10, 3 and 5, 2 and 5. What else can come out? I already have a 6. I already have an I. What else can come out? A 5. And what's left inside? 3 times 2 is 6. So what does this get me when I multiply it all? 30i radical 6. Okay. And then finally, number 8. I have a negative 3 out front. I need to think of the square root of negative 27 as the square root of negative 1 times the square root of positive 27. And the square root of negative 1 is I. So I have a negative 3 times I times, let's see, what can come out? 3 and 9, 3 and 3. What else can come out? So I have an I, and I have another 3, and what's left at home? So negative 3 times I times 3 is negative 9i radical 3. So the negative outside didn't affect anything really. It just meant that I had a negative 3 when I was multiplying. The negative inside is what causes us to get that imaginary number in there. Okay? Questions? Pretty similar to yesterday, right? Just that one extra thing. All right.